Welcome to our class today, where we're going to look at optimization, specifically revenue analysis and profit maximization. So optimization is at the heart of managerial economics, at the heart of decision making. So all businesses aim to get the best outcome given the scarce resources, given the competing objectives. So when you're talking about optimization, what are we talking about? We're looking at maximizing profits, maximizing revenues, maximizing shareholder wealth. So when we say we are optimizing, we are maximizing. Okay. To also optimize means to minimize risks, to minimize costs, to minimize losses. These all fall under the umbrella of optimization. So the picture in practice here is that when we're optimizing under economic theory, we're using mathematical tools to identify optimal levels of outputs, of inputs, of pricing strategies that will give us a maximum benefits. So the two central applications in economics that we're going to look at are revenue analysis and profit maximization. So we're just from discussing the demand theory, which is given by A minus BQ. Okay, for instance, if we have 100 minus 2Q, this is our direct demand function, our inverse demand function. So we will learn a bit of some calculus. So total revenue is simply found by multiplying the price times the quantity. Average revenue is found by dividing our total revenue over our quantity. Our marginal revenue is given by the change in total revenue over change in quantity. If you're using calculus, it is given by the TR over the Q. So marginal revenue is simply the additional units that we have for enjoying an additional unit. So to maximize revenue, we maximize revenue and the marginal revenue is equal to 0. The maximum revenue is simply a point of output where our total revenue is maximum. So this point here, where total revenue is maximum, that is where we have our maximum revenue. So we're going to do a few calculations here so that you understand the basic. So we're using this demand function. P is equal to 100 minus 2Q. How do we find the total revenue? Total revenue is what? Price times quantity. What is our price? 100 minus 2Q. Now quantity is just letter Q, you impute it here. So our total revenue in this case becomes what? 100 times Q is 100Q. 2Q times Q is a 2Q squared. So this is how we find our total revenue. Then we differentiate. So differentiation is given by the TR over the Q. finding the derivatives. So what is the derivative of 100q? It is 100. What is the derivative of 2q2? It is 4q. So this is how we differentiate. Differentiation follows the power rule, which simply states that if you have a function ax to the power n, so differentiate dy over dx is simply multiplying a coefficient and the exponent, then subtract 1 from the power. So if you're going to have a number 5x to the power 4, you're just multiplying the numbers. 5 times 4 is 20, and subtract 1 from the power 3. Let's try. If our y is 10x to the power 3, how do we differentiate this? It's the letter on the left over the letter on the right side. So this is dy over dx to start with. Then we multiply the numbers. 10 times 3 is 30. Then subtract 1 from the power there. 3 minus 1 is 2. So this is what we call a derivative. So this is what we did in like manner. If you're differentiating a constant, so if you're going to have y is equal to 10x4 minus 6x3 plus 5x2 minus 7x plus 9. So we're differentiating the letter on the left side over the letter on the right side. So this is dy over dx. Then what is the derivative of 10x4? 40x what? x3. What is the derivative of 6x3? Minus 18x2. What is the derivative of 5x2? 5 times 2 is what? 10. And we subtract 1 from the x squared will be x to the power 1. 1 is invisible. Then 7x, there's an invisible 1 there. 1 times 7 is 7. 1 minus 1 is 0. So 7x is 7. 10x is 10. 1x is 1. Then if you have a constant, it falls out. Okay, so if we had total revenue as 170q minus 5q squared, what do we have when you differentiate this? The TR, the letter on the left side, there are two, take them as they are, over the q. So 170q is 170 minus 5q2 is 10q. So this is the derivative of the total revenue. Of course, you need to understand that when you differentiate total revenue, the name changes to marginal revenue. When you differentiate total cost, the T just becomes an M. We're going to have marginal cost. Okay. Total profit will be marginal profit. So I want us to really learn how to differentiate, because this is the foundation of optimization. This is the foundation of optimization. Any questions so far? Are we following?
It's clear from my end.
Right. So we To understand revenue analysis, we must understand these particular important formulas. So revenue is simply the income that what? One earns from a sale. That is what we call revenue analysis. So income is simply, or revenue is simply income that a firm will earn from selling a good or service. So the key determinant of profitability when we're dealing with financial stability. So we have types of revenue, what we call the total revenue, which is price times quantity, or what we call the average revenue, which is total revenue over quantity, which is usually the price for a monopoly, for a perfect competition. Marginal revenue is simply the change in total revenue over quantity. So with these formulas, suppose we're given a table to fill in 1, 2, 3, 4, 5. You're given your price, then for 15, 20, 8. So what is our total revenue? What becomes our total revenue? What becomes our average revenue? What becomes our marginal revenue? The revenue is price times quantity. Just multiply them. This is 10. This is 24. This is 45. This is 60, 80, and this is 150. Just multiplying price times quantity. Average revenue, we divide total revenue over 1. So 10 divided by 1 is 10. 24 divided by 2, 4. 45 divided by 3 is 15. 80 divided by 4, 20. And 150 divided by 5 is what? 30. So discover that the average revenue is the same as the price. No wonder this statement here. Then marginal revenue is the additional units on total revenue. So this minus that over this minus that. This one is a dash. 24 minus 10 is 14 over 1. So there are ones throughout here. But 5 minus 24 is 21. 80 minus 45 is 35. 150 minus 80 is 70. So this is a marginal revenue, the additional revenue that we're getting. So sometimes we'll be given in terms of a function. Price is equal to 170 minus 5Q. Find the total revenue. Total revenue is what? Price times quantity. So price is 170. Quantity is 5Q. So we impute the Q. And we're going to have total revenue as what? 170 times Q is 170Q. 5Q is 5Q squared. So we're going to have that as our total revenue. When we differentiate the total revenue with respect to quantity, we call this a marginal revenue. The marginal revenue in this case is given by what? 170Q is 170. 5Q squared is 10Q. So this is how we find our marginal revenue. So when we cut the marginal revenue to 0, we are simply maximizing the total revenue. So 0 is equal to 170 minus 10Q. So we solve for Q and P. When this one comes inside, we're going to have 10Q is equal to 170. So we solve for Q, divide both sides by 10, and our Q therefore will be 17. So how many units will maximize revenue? 17 units. At what price? We go back to the original price here. So where there's where there's Q, you put what? 17. So this will give you 85. So 85 is simply the maximum price that will maximize revenue. Okay, so don't mind my graph. Yes. Total revenue, it maximizes at the price of 85, and the number of units that will maximize is, say, 17. So this is half of this, so meaning here we're going to have 34. So this is our total revenue function. So revenue is maximized at this point. Total revenue is maximum at this point. And the revenue that maximizes what? Revenue that maximizes your the price that maximizes your revenue. Okay, so this is revenue analysis. Are we together? Okay, we're together. So I'll give you an exam question type we look at. But you must also understand that there's a relationship that exists between what? Total revenue, average revenue, and marginal revenue. So in a perfectly competitive market, okay, this is our marginal revenue, so average revenue. Okay. So where total revenue is maximum, that is where the marginal revenue is equal to 0. Okay. To maximize what? Our total revenue. So the relationship that exists is that when average revenue is constant, our marginal revenue is equal to our average revenue, which is equal to price in a perfectly competitive market. So this is a point where the price is equal to average revenue is equal to marginal revenue. This is a point where our average revenue is constant. So when average revenue is sloping for a monopoly, marginal revenue becomes less than the average revenue. So here, marginal revenue is less than the average revenue. This is in a monopoly. So total revenue is maximized when marginal revenue is equal to 0. So this is where we maximize what? Total revenue. Total revenue is maximized here. So graphical representation, the total revenue will first rise, then it'll reach the maximum, then it will decline. The average revenue is downsloping in an imperfect competition, so it's downsloping, whereas the marginal revenue is also below the average revenue in a monopoly. So in terms of elasticity that we were looking at yesterday, okay? So downsloping, we have 3 key points here, okay? When demand is elastic, price of demand is greater than 1. So we have a lowering price. So here, elasticity is greater than 1. And here, when demand is unitary, total revenue remains unchanged. So here, elasticity is equal to 1. Total revenue is unchanged. When elasticity is less than 1, then we have a rise in price. So you need to understand these relationships that exist in those three arenas. Okay, so we go back to our discourse. Let us maximize our revenue if we are given any questions so far before I proceed as much? So I want to go to profit maximization. When do we maximize profit? What is profit? Profit is simply the difference in our total revenue and our costs. Profit is given by the symbol pi is equal to TR minus TC, where pi is a profit, TR is a total revenue, and TC is the total cost. So when we want to maximize profit, the marginal revenue must go to the marginal cost, or the marginal profit must go to zero. So under cost theory, you must understand that costs are divided into two. The total cost is simply equal to the fixed cost plus the variable cost. The fixed costs are constant. Variable costs are variable. So when you combine these two, they will give you a total cost function, which looks like this. This is fixed cost. This is variable cost. So collectively, they make up a function which looks like that. So our total cost here, if it's given by 10 plus 5Q. Our 10 is simply the fixed cost. So the autonomous part is here. So the formulas, total cost is equal to fixed cost plus variable cost. Anything divided by quantity is average. So variable cost, when you divide it by 2, it becomes average. So this the average fixed cost, because we divided the fixed cost by 2. This is average variable cost because we divided by Q, the total cost. We can put a T there if you want. The T becomes an A. Total fixed cost, when divided by Q, becomes average fixed cost. Total variable cost, when divided by 2, it becomes average variable cost. And total cost, when divided by 2, simply becomes average cost. So graphically, you need to know that these are just episodes of C's. Okay? Average total cost, half of it is marginal cost. Then the entire cap, when you add all these, this is our average cost. So average costs have a U shape. So if you're given your total cost as 10 plus 5Q, so show me which one is a fixed cost. Fixed cost is what? The 10, the constant without the number. Meaning the average fixed cost will be when you divide the total cost by Q. So this is the fixed cost over quantity. So 10 per Q. And the variable cost is 5Q. When you divide the variable cost by quantity, it becomes the average variable cost. So we divide the total variable cost over quantity. So what is our total variable cost? 5Q. When you divide by Q, we're going to simply get a 5. So when you add the average total variable cost plus the average fixed cost, the total that you get is called the average cost. So our average variable cost was 5, and our average fixed cost was 10 over Q. So collectively, what we get is called our average cost, average total cost if you want. But still, average total cost is simply the total cost we divide by quantity. What was our total cost? Our total cost was what? 10 plus 5Q. So we divide both sides by Q. Well, not both sides, but each individual. So 10 over Q is 10 over Q. 5Q over Q is simply 5. So this is what we call our average total cost. Are we together? So cost theory is very important in optimization because it helps us understand how the cost behavior operates. Okay, so I will now bring the aspect of profit into the picture. So profit, we said, is simply the difference between what? The total revenue minus the total cost. So suppose we're given our price as 170 minus 5Q. And we're given our total cost as, let's say, 40 plus 50Q plus 5Q squared. Who can help me? How do we find our total revenue? Total revenue is got what? Price times quantity. So our price is 170 plus 5Q. Then we impute the Q at the end here. So meaning our total revenue is 170 Q minus 5Q squared. That is our total revenue. That becomes our marginal revenue. We differentiate 170Q, n number with one letter at the end, just that number. 170Q is 170. 5Q squared is 10Q. Then our total cost has been given as 40 plus 5, 50Q plus 5Q squared. So when you differentiate the total cost, it becomes marginal cost. The T becomes an M. So we differentiate the TQ, the TC over the Q with the marginal cost. So let's differentiate this. 40 is a constant, it drops out to 0. 50, Q differentiated is simply 50. Whenever there's just the power 1, just get the number there. Then 5Q squared, we get is a 10Q. So how do we maximize profit when marginal revenue is equal to marginal cost? So let's equate these two. Marginal revenue should be equal to marginal cost. So marginal revenue is 170 minus 10Q. And our marginal cost is 50 plus 10Q. So the like terms together. 170 minus 50 is 120. 10 plus 10Q is 20Q. So when we equate this, we're going to have 120 is equal to 20Q. So we divide both sides by 20. So we're going to have our Q is equal to 6. So how many units will maximize our profit? 6 units. At what price? You can put this in the original price function. So 170 minus 5Q. Where there's Q, we put a 6. 5 times 6 is 30. 30 from 170, you get 140. So this is how we get the optimal value that will maximize the profit. Now the question still remains, how do we get the profit function? The profit function is total revenue minus total cost. So what is our total revenue? We calculated our total revenue as 170 Q minus 5Q squared. What is our total cost? It was given as what? 40 plus 50Q plus 5Q squared. All right. So now we put the like terms together. So what happens here? The negative, in this case, will negate the negative aspects. So minus 40 minus 50Q minus 5Q squared. So you put the like terms together. So 170Q minus 50Q. Then we have minus 5Q squared minus 5Q squared. Then here the 40 remains alone. Now we're following. So 170 minus 50 is what? 120Q. Minus 5 minus 5 minus 10Q squared. And the 40 is simply alone, it will be minus 40. So this is a profit function. So using the calculus, you can simply differentiate the profit, then you get to zero, you will get the same answer. So what is the derivative of the profit here? You can put one apostrophe there to show that you have differentiated. 120Q is 120. 10Q squared is 20Q. What happens to the 40? It drops out. So when you get to zero, you're going to have 0 is equal to 120 minus 20Q. When this one goes this side, the 20Q will be in this part here. And here 120. We divide both sides by 20. Our Q will remain to be what? Remain 6, as we found here. And the price, we put it in the original price, we get 140. So this is how we maximize our profit. So this is maximization. Is that clear? Any questions? Am I too fast for you? Are you following me?
We'll follow you.
Okay. So now I can bring in the exam question to do with revenue maximization at this point so that we can see how questions come in that regard. Is that okay? So we quickly look at one of the papers and maximize based on what we have talked about, then I give you homework. Okay, so try to look at this paper, 2023 paper. Or the 2024 paper, the deferred exam. Okay, so is there any question to do with maximization. Okay, so I'll send you questions that are varying from different papers just to give you homework on what we have learned. So for now, we'll end here um, so that I can leave some space for the others to join. Okay, we can end here.